Okay, so let's talk about Pythagoreans Theorem again. This time, let's look at, we have these 4 examples of Pythagoreans Theorem on the coordinate plane. So if it's in the coordinate plane, the distance formula is used, which is Pythagoreans Theorem, a squared plus b squared equals c squared. So let's just start with using the distance formula and look at the length of AB. Well, we have our ordered pairs of all this over here, so let's just use the distance formula to calculate it. And so it's again x2 minus x1. So if I'm talking about my ordered pairs, if this is ordered pair 1, right, I'll put a 1 there, and this ordered pair 2, then I would call this x1 y1, x2 y2. Now I could switch it up and I could call this x1 y1 and x2 y2 just for the idea, but what we can see then is this is the ordered pair 1 1, and this is 4 5, right, over 1 2 3 4 1 2 3 4 5. So my ordered pair is 4 minus 1 squared, right? If I use x1, this is x1, so I should start with 1 minus 4. Oh no, I start with 4. So x2 minus x1 plus y2 minus y1, right? 5 minus 1 squared, and that should give us the segment length. Well, we get 3 squared plus 4 squared, and of course I'm only putting it in parentheses just because it stays consistent that way, but you don't really need them unless there's something else in the group. So that's just the square root of 9 plus 16, which we've already seen in prior videos is the square root of 25, which simplifies to the segment length of 5. But what I wanted to show you, of course, we can use this distance formula for all of this to calculate it, and there's a little bit of labor to it, but if you just make right triangles, and what do I mean by make right triangles? In your on your grid, just take a horizontal line and a vertical line and intersect them so that when I go horizontally and I go vertically, they intersect at a right angle, and then this point right here forms a right triangle with A, B, and some new vertex point down here that I can use. So this point right here gives me a unit of 3 and a vertical unit of 4. And then of course this just becomes, right, a squared plus b squared equals c squared if I look at it from that perspective. So I mean, I can do all this, but I'm getting the 3 and 4 anyway here from the distance formula, just saving myself a little bit of time or potentially errors in calculating. So and of course that would cross that out, so that would just give us that 5 for the values C in that diagram. So let's just kind of look at this next triangle and see if we can't speed this up a little bit. So we are just doing the same thing. So I guess I'll stay consistent. I'll use blue for the horizontal, and I'll use red for the vertical, and just so you see that when I do that, right, I end up with 2 units this way and 3 units this way. So I can kind of think about, well, this was for segment AB. So for segment CD, I know that it's going to be the square root of 2 squared plus the square root of 3 squared, right? Just like the other one was 3 squared plus 4 squared. Well, what is the square root of 2 squared? It's 4 plus 9, so square root of 13. So this length here is just the square root of 13. Alright, well, let's continue this same idea, and if you want to pause the video and see if you can find the last 2 while I'm working them out, and then check, you should, just to see if you have the idea, and then you could verify them using the distance formula to make sure you do this correctly, and then you'll know the tools. And these are the same thing. Almost every situation comes up this way when we're talking about Pythagoreans Theorem in the coordinate plane, or in other situations. You're basically doing these 2 things. Now there's other stuff, but as you build, this become easy. So this is just a 1 unit distance, and this is 1 2 3 4. So that's just 1 squared plus 4 squared, right? That will equal EF squared, right? Or the square root of that equals EF. So 1 plus 16, the square root of 17 is EF. So that's this side is the square root of 17. And notice that it's this squared plus this squared, square root of that. And the last one, before we go too deep into kind of this, and of course these were all in the coordinate plane. They don't always have to be. I can, in matter of fact, most of the time they just won't be. They'll just be in some format of a diagram or some real-world application, because Pythagoreans Theorem is used in a lot of real-world applications. But let's take a look. This distance here is 2. I'll use my pencil. And then this distance 2 is 4, and then 4, so this is 8. So I know that HI is equal to 2 squared plus 8 squared, and that the square root of that is my segment length, HI. So, okay, that's 4 plus 64, right? That gives me the square root of 68. All right, so now I have to wonder, is there a perfect square factor that goes in this? And I guess 4 goes into 68, and it goes in 17 times. So I'm going to factor, just because it's always good practice. These two multiply to be 68, so I factor them out, which pulls out a perfect square value. And so the segment length is 2 square roots of 17 for HI. And that is just applying Pythagoreans Theorem in the coordinated plane. But notice I used what we have here, the distance formula, to calculate it. And I probably should just go through it real quick on HI, just so you see, because there's some negative values, just to see, do I still get this 2 square roots of 17? So I'm just going to do that just to verify it. It's always useful. You don't have to do it, but if you want to do it along, just to verify. And if I use those two, this would be my x1, y1, x2, y2. And again, I could switch them around. So if I start with x2, I'm going to say 4 minus negative 4, right? This is my x values, 4 minus negative 4, if I say x2 minus x1, right? For the distance formula, which is what we have. And then I'm going to be plus, and then it's going to be negative 1 minus 1 squared. And so this is where it gets very difficult, right? Because this is 4 plus 4. And this is a very easy place to make mistakes. And what do we end up with? We end up with 8 squared. And this is negative 1 minus 1, which is negative 2 squared. And I can kind of already start to see that I have this length of 2 and length of 8. So I'm already getting to the point where I calculated. But notice with these negative numbers, if I'm not careful, I can miss the distance actually, because distance should be positive. So when we square it, it does allow us to fix that issue. And that's where we get that 64 plus 4. And so we do end up back to those two positive values, which allows us to then get us to the square root of 68. And of course we would simplify the same way, so I'm not going to go ahead through that with you right now. But those are 4 examples, and hopefully they help, or at least you've gotten a better handle on it. So